All right, ladies and gentlemen, welcome to this video solutions for Builder 3. We will begin with number 1, find the domain and range. So this is an interval. It's not a complete continuous function with little arrows at the end. So all real numbers doesn't apply to this particular situation. So we'll start with the domain. Okay, and we know that domain is x. Okay, so the way I'm going to solve this is I'm going to figure out what are the coordinates of these 2 points. So here's one coordinate, 1, 2, 3, 4 is the y value, and the x value is 0. Okay, and then over here I'm going to find these coordinates. We'll see 1, 2, 3, 4, 5 is the x value, and the y value is 0. Because this is the y-intercept, and this is the x-intercept. Okay? So now I would just identify x and y. You'd say, x, y, x, y. And I know that with domain, I'm going to be dealing with the x's. So there it is. Okay? You just put the smallest x first. So if we're talking about domain here, and this would be your answer, you would just put the smallest x first, which is 0. Okay, and then the big X goes over here. That would be 5. We know that domain is x, and then here's your 2 inequality symbols. So we say 0 less than or equal to x, less than or equal to 5. AKA, okay, in other words, like such as, therefore, x can be any number between 0 and 5, including 0 and 5. Okay, and we know it's less than or equal to because it's a filled in dot. Now we'll do range. Okay, we know range is y. So if you want to start thinking in like a template form, you could go ahead and put your y here and put your symbols on either side. Now you just need to figure out what those numbers are. Okay, so what is the smallest y value that this thing can be? 0. Okay. Okay. So let me find a way to highlight that there and there. Okay. So I'll go ahead and highlight this and say range, and we make sure we say it's y. All right. And get my values all highlighted here. And so I'm just going to put the smallest y value, which is 0, up to the highest y value, which is 4. Ladies and gentlemen, brothers and sisters, comrades and friends, that is the answer. Okay, that wasn't that bad. Let's move over to number 2. Find the domain and range. Now, this is a quadratic function. Right away, we should take a minute and figure out what our important numbers are. Okay, for domain and range, we don't care so much about these numbers here. Right? These are the x-intercepts. They don't matter for domain and range. Okay? They don't matter. Here's the point that really matters. The vertex. And it really matters, guys. I need to know what the x value is, and I need to know what the y value is. And the important value is the y value. So let's figure that out. The x value, that's 1, 2, 3, 4, 5. The y value is, let's see, if I do this. Okay, let's see, 1, 2, 3, 4, 5, negative 5, right? So I'm down here at negative 5. 5 comma negative 5. This is the important number. This negative 5. Okay, so notice that these arrowheads are going up forever. So they're going up to infinity. All right? And, this thing will go down, and it's going to stop here, and the lowest value it can be is negative 5. So my range is negative 5 to infinity. So again, your template's going to look like this. And the bottom number is -5. And then infinity goes over here. Now, domain is really easy. All real numbers. Now, we don't write, you might write all real numbers, and we could write all real numbers. In fact, I will write all real numbers, just so you can remember that. All real numbers. But the kind of inequality notation here is -infinity less than or equal to x less than or equal to positive infinity. Okay? And that is the answer. Okay? Was that all that bad? No. Not all that bad. Okay, moving on. Hey, I didn't give any room here to work, so this must be easy if you know what I'm asking you. So let's look here at number 3. Number 3 is asking us for domain, so I'm automatically thinking x. Okay, and when I see f of x equals, I'm automatically thinking y equals. Okay, so f of x equals 5, y equals 5. The question is, what does the equation y equals 5 look like? Okay, yeah. It has no angle to it at all. It is as flat as Kansas. So there's no x over here, right? It's just a whole number. So that means that it's a straight horizontal line. Okay. It is a straight horizontal line passing through 5. Right? Sometimes it's helpful to have a picture. So let me ask you a question. This is x, this is y. Domain is x. What x values can this be? Infinity to infinity. Okay, negative infinity all the way to positive infinity. Can literally be any x value that's a real number. So for domain of any flat line like this, you would just say all real numbers or negative infinity less than or equal to x less than or equal to positive infinity, or all real numbers. You know, when you get up in school, you'll write it like this. That weird looking R. All real numbers, what that means. Okay? That was number 3. How about that? Was that hard? No, that's all right. Now, number 4, a little bit of a different question. Let's think about this. Don't think about it like math. Forget about think about it like you're the guy, okay, or the girl. You're the electrician. Do you guys know what a trip fee is? What is a trip fee? It's the base fee you're going to pay this person to come out to your house. It doesn't matter if they have to flip a breaker or rewire the house. You're going to pay that base fee for them to come out. Even to give you a quote, sometimes they're going to charge you a trip fee. So this dude, we're thinking about how much money this dude's making. Well, he's definitely going to make 50. That is the least amount of money this dude is going to make today. All right. If he gets even one call, he's going to make $50. So eventually we have to figure out what the range is. Well, what is the lowest number that it could possibly be? 50. So we already know part of this answer. Okay. This is the range. 50 less than or equal to y less than or equal to. Now we got to figure out the maximum amount of money he can make today. Well, let's read the question or the prompt. All right. So he charges $80 per hour. Wow. That's big money. All right. And he's only going to work a maximum of 10 hours per day. So on a per hour basis, if he works 10 hours, how much does he make all day? $800. There you go. So you add the trip fee to the amount of money that he made while working all day. So $850 would be the range. And this is kind of a simplistic problem. It's assuming that he only makes one trip. Like, you know, it would be interesting, honestly, if it added in, he made 10 trips. You know, he went to 10 different clients and worked a max of 10 hours. Then we could mess with that. But this keeps it more simple. Gentleman over here with the cowboy hat had it right. It's $850. So here's the maximum amount of money he can make today. Was that hard? No. No, it wasn't hard. So if y'all see another question like that, where next to sound an electrician, maybe it's maybe it's a plumber, or maybe it's another trade worker like a HVAC repairman or repair person, you would know what to do. You would know what to do. Let's move on to number 5. What is the domain of x equals -2? Okay. This is one of those things that I can't teach you. I mean, I can't teach it to you. I just have to tell you it over and over again until you can really remember this. There's no y here. You see, it's not y equals. It's no f of x. It's just x. X equals -2. What does that look like? That's exactly right. It's a perfectly vertical line, okay, going straight up and down through -2 on the x-axis. So here's a little picture of it. Oh, I'm on 6. Perfect. Thank you. Okay, so here's the picture of it. This is y and this is x. And we'll just call this -2. Well, the line, when you put it in the calculator or graphing software, would be a perfectly vertical line like this. Okay. So domain is x. So we can zoom in on this. What x value can this be? Only -2, okay? Only -2. What do you think the range of this would be? Infinity, yeah. So we're going to find a way to say what you said, only -2. You ready? We're going to put x here. -2 to -2. That looks harder than it is. I mean, only -2 was a lot easier. You might also see it like this. Okay, 2 different ways of saying it. Or, I actually like this, only -2. So if you're looking at multiple choices on a STAR test, you just pick the one that kind of says what you're trying to say in your head. Was that hard? No. Okay, number 6 is right below it. What is the range of f of x equals -2/3? Well, first we got to get a picture of it, okay? Is this a perfectly horizontal line or is this a perfectly vertical line? Or neither? Horizontal. y equals negative 2/3, or you could say y equals 0.6 or negative 0.6 repeating. This means that there's going to be a flat horizontal line going through negative 2/3 on the y-axis. Okay, so we'll call this negative 2/3. And here's our line. Okay, the domain is all real numbers. See, that domain is going to infinity in both directions. But the range, what's the range? It's just negative 2/3. So remember, you're being asked for the range here. Up here, you're being asked for the domain. So we're doing range. We know it's negative 2/3 less than or equal to y less than or equal to negative 2/3. Or you could just write negative 2/3 like this. Okay. Or only negative 2/3. The takeaway I wanted from these two questions was to show you when it's x equals something, a number, x equals a number, and you're asking for domain, it's only that number. When it's y equals something and you're only asking for the range, it's only that number. Okay, because range is y and domain is x. That's why. All right, number 7. What is the domain of f of x equals 3x squared plus 2x plus 5? What type of equation is, or what type of function is this? Quadratic. I want you to write this down. All quadratics have the same domain. What is that domain? All real numbers, or negative infinity less than or equal to x less than or equal to positive infinity. Okay, you might also see it like this. Well, you might also see it like this. Different ways of saying all real numbers. And that's only domain. Range is harder on quadratics, but the domain's always going to be that right there. Unless you're given some other information that would lead you to think that it isn't, then that's what it is. And I think we're going to see one here, here on number 8, where you are given some information that will change the domain. Okay? So was that hard? You had to just know that, didn't you? You have to know that, okay, that's a quadratic. And the way that we knew it was a quadratic was because the highest exponent is 2. All right? When you see that squared, you know it's a quadratic. Let's look at number 8. An object is launched from a height of 100 feet, and it hits the ground after 13 seconds. Okay. It helps to imagine this, like, so you can see what projectile motion looks like. Ready? This is the object. It's 100 feet up in the air. Now watch. See, it's going to go, it goes up a little bit, and then it comes down, right? Goes up, goes down. So notice this. The launch point is not the highest point that this thing gets to. See? It goes a lot higher than where I let go of it. Think about a football. You're standing whatever you are, 6 feet tall. You throw the football, right? It's going to get higher than your arm as it makes its arc, and then it's going to start to fall. What's pulling it down? Gravity. Okay? Yeah, I guess I'm through throwing stuff around. That was fun. So the range is not going to be 0 to 100. It's going to be 0 to the highest point. So we got to figure out what this number is right here, because this is going to be the y value of our vertex. Can you see that this is the vertex? You could call it the highest point. It's also the vertex. What's that? Yeah, let's see. We go down and read a little bit more. It says the maximum height is 120 feet at 5 seconds. That means that right here, this thing has been traveling for 5 seconds and it's reached a maximum height of 120 feet. This is the highest point. So I know that my range, we'll do the range first. My range maximum is 120. So now I only need to know the minimum range. What keeps happening to these cups of ramen? They keep hitting the floor. So let's call the floor 0 feet high. So what is the range of this motion? The lowest point it ever gets to is 0. The highest point it ever gets to is 120. So the bottom end of this is 0. Now let's look at domain. So I just got through telling you all quadratics have an infinite domain, but look at this problem. This problem gives you some additional information. It's saying that this problem only exists on this limited interval right here between 0 and 13 seconds. Okay? The ramen bowl, at 0 seconds you start a stopwatch. 13 seconds later, it hits the ground. So the domain of this is 0. Good job. Okay, and bingo was his name-o. All right, was it that hard? No. During the STAR test, you should keep 4 or 5 cups of ramen next to you and just, when you need to, throw them up in the air. Okay? And let the test administrator know that you're simply trying to visualize the problem. Okay? And that was it, guys. I want to let you know that I basically just rewrote a question out of the STAR test using different numbers. So that was easy. Number 9. Let's go find that. Where is it? Over here. Parents. What? No. These are called parent functions. Well, we're going to talk about this here. The parent linear function. See, there's these things called parent functions. And you could think of all the other equations that you could possibly make up as like children of this bigger function, or this kind of ancestral function. And here's the parent linear function. Key word here is linear. The parent linear function, well, write this down, this is important. Here it is, ladies and gentlemen. F of x equals x. Now look what the problem tells you happened. It says it shifted left 5 and then shifted down 6. So these are called transformations. This is called a horizontal transformation. Give you 2 guesses what the other one's called. Vertical transformation. As kids, you are currently going through a vertical transformation. You're getting taller. Me, I already did all of my vertical transforming, and as you notice, I'm now transforming horizontally. I'm getting bigger, okay? Wider now. Okay, so how do we do a horizontal transformation? Let me show you. It's a great question. Thank you so much for asking. Let me show you how to do it. You take f of x. Okay, set that equal to, open parentheses, x. Now it's a shift to the left. So you want to say minus. Raise your hand if your head is telling you that left should be a minus sign. It's the opposite of what you think. So you will still think that on star test day. So the moment you think left, that's minus, just think the other symbol. So what is it? Left is plus. Now, does that make any sense like in your head? No, it doesn't. But if you do it in the calculator, it's what it is. So x plus 5. That means, here's what that means. This is important. This means move left 5. Okay? Now it says move down 6. Well, this one does obey your intuition. So what do you think I'm going to write now? You're going to just write minus 6. You're going to throw that minus 6 on the end of your thing. So the important deal here, guys, is these parentheses. You must put your horizontal transformation in parentheses with the x. Otherwise, it won't work. So remember, all we're doing, we're taking a line here. This pen is the line. We're moving it. Well, for y'all, it would look like this. We're moving it left 5 spaces, and we're not rotating it or anything. And then we're going to move it down 6. So let's simplify. F of x equals x plus 5 minus 6. What does that equal? X minus 1. So f of x equals x minus 1. And that right there, ladies and gentlemen, is the function after it has been shifted left 5 units and down 1 unit, or down 6 units. And here's what happened. You went from this, okay, to this. But this transformational equation actually makes more sense. So look what happened. The x had 5 added to it, and then 6 was subtracted from the whole thing. Now, this was kind of a simple example because there was the slope of the function was 1, so there was nothing weird going on. But that's a transformation. Now, this is a linear transformation. You ready to look at a quadratic transformation? So first, let's figure out what the parent quadratic function is. This word parent means something important. Okay, the word quadratic is also very important. So here's the parent quadratic function. F of x equals x squared. All horizontal transformations will happen like this. Whatever you're going to do, it'll be f of x equals open parentheses x plus or minus something, close parentheses squared, and then you'll either be moving up or down something else. So this is the template. I want to kind of erase that before you can write it down. But we're going to do it now. Okay. Okay. So what does it say? It shifted right 7. So if left was plus, right must be minus. And then it goes down 10. So that's minus 10. So let's write this again. F of x equals open parentheses x, minus 7, close parentheses. Don't forget the squared. Minus 10. Does this form appear like anything? Does this give you any information? Do you see this is a form of a quadratic function called vertex form, right? Remember x minus h, x minus h plus k, x minus h squared plus k. You can tell me the vertex of this right now. So the vertex is going to be at 7, comma, negative 10. That's pretty cool. I mean, that's not, the problem didn't ask that, but just, it's pretty cool. So if this was the answer choice, this would be it. But you know what? The star test will probably have it in standard form. This is vertex form. So remember what you did. You transformed from this to this. Okay, here's where we are now. Let's transform this from vertex form to standard form. You ready? Here's how you do it. F of x equals, now it says x minus 7 squared. So we're going to write x minus 7 times x minus 7. And then all that minus 10. And now we do FOIL, first, outer, inner, last. So f of x equals, first, that's x times x squared, outer, minus 7x, inner, minus 7x, last, plus 49, minus 10. Just combine like terms. Here's some like terms. Here's some like terms. So we'll kind of put this dude up here. F of x equals x squared minus 14x. And then what's 49 minus 10? Plus 39. So I can't tell you what the test is going to ask you. It's either this or this. That one was kind of hard, huh? Hopefully they give you vertex form, and you could do that one. Now, this parent exponential function shift is really easy, okay? Now we're getting good at this. I've given you the function f of x equals 2 raised to the x power. So now I'm going to shift right 3. That means x minus 3, and then down 2, minus 2. So here's my answer. F of x equals 2 raised to the power of x minus 3 minus 2. Okay? And as ugly as that looks, that's the answer. Okay? Well, that's not the end of it all. It's asking us for the equation of the asymptote. Do you remember what that means? It's the wall, okay? It's the wall. So for this, I do need to show, I want to show Desmos so you can see. Okay, so let's type in the parent function that we were given, y equals 2 raised to the power of x. Now watch what happens. Let's make sure our transformation really did what we said. Y equals 2 raised to the power of x minus 3 minus, look what happened. It shifted to the right, and now we're going to shift down 2. Look what happened. So now, all right, so the question is, what is the equation of the horizontal asymptote? What do you think it is? What is this? What is the y value approaching? No, look at the y value there. Look at the y value as it's, what's it getting closer and closer to? -2. Okay, so look, as you get further away, it gets bigger and bigger, but it's never going to go below -2. Look, if we zoom out. Yeah, I'm talking about the y value. Look at that y value. It's at -1.988 right now. Now look, here it's going. It gets to -2. Look, it never goes below it. Okay, so how do we write an equation of a horizontal line passing through -2 on the y-axis? Very, very good. You see, there's your asymptote, ladies and gentlemen. Y equals -2. So we wrote the new function, and now the asymptote, we'll call this the horizontal asymptote, is y equals -2. Great job. Great job. Like Tony the Tiger. You're great. Oh, eerie. That was eerie. Please don't ever say that again. Okay, number 12. This is easy. Let's do it quick. Find the slope of a line parallel to a line passing through 2, 9, and 6, 4. Guys, when you see this word, parallel, here's what I want you to think or write down in your head. Ready? Same slope. Okay, think about skis. Here's two skis. They have the same slope. Parallel lines have the same slope. So all we have to do is find the slope of these two, x1, y1, x2, y2. And then we have the answer. Because whatever the slope of this line is, it's the slope of any line parallel to it. So let's find the slope. That's m. y2 minus y1 over x2 minus x1. Okay, ladies and gentlemen, just plug it in, plug it in. 4 minus 9 over 6 minus 2. 4 minus 9 is -5. 6 minus 2 is 4. So this is the slope. This is it. That's the answer. You're done. You're done. Oh, that doesn't look good. Okay. Number 13. Find the slope of a line perpendicular. Guys, perpendicular. Here's the words coming in your head. Okay? Like you're being possessed. Negative, reciprocal. Negative, reciprocal. Hey, just so you understand, negative reciprocal. If you have a number and you want the negative reciprocal, that's -1 over that number. All right. So negative reciprocal. So first we have to figure out what this slope is. Well, they haven't given it to us in the slope-intercept form. So we got to kind of do this little distribution. -4 times 2x is -8x. -4 times 2 is -8. So this is my original slope. So if m equals -8, which it does, then the negative reciprocal of m, okay, -1 over m equals, think about it, -1 over 8. So that equals 1 over 8. Right? Okay, let me do this again because I kind of messed it up. So -m. We take -8, put a 1 over it, and change the sign. All right? So that's how we got to +1 over 8. Put that in a box. We're almost done. 2 more to go. Write in slope-intercept form. Okay, what form is this? This is AX plus BY equals C. What form is that called? You can say point slope, standard, intermediate, slope-intercept. What do you think it is? Standard form. So we're going from standard to slope-int. Okay, that's y equals mx plus b. So I'm going to get y by itself on the left and put everything else on the right. So first thing I'll do is subtract 2x from both sides. And then I'll have -3y equals -2x plus 5. And then just divide every term by -3. Cancel, cancel. y equals 2 over 3x minus 5 over 3. That's the answer. Was that hard? No. Just a little bit of math. Number 15. This is the last one. Write in slope-intercept form. What is this form called? Hey, check this out. Ready? It's y minus y1 equals m, open parentheses, x minus x1. What do we call that form? Point slope form. So now we're going from point slope to slope int. Hey, look, if you look at it carefully, you can even tell what the original coordinates were. What's the slope of this, by the way? 3. The original points that they stuck in there were 7 on the x, on the y, and 2 on the x. So it was, the way they formed that was it was slope of 3 passing through 2 comma 7. See how they did that? Okay, so now let's fix it. Let's turn it to slope-intercept form. We're going to distribute the 3. So we got y minus 7. Remember these two homies just hang out? Now we got 3x minus 6. Add 7 to both sides, and we're done. Negative 7 plus 6 is plus 1. Was that hard? No. Okay, zooming out, let's just take a look at all of our work here. Which one did you find the hardest?
Number 2.
Number 10? So we need to work, if what I'm hearing is correct, we need to work on our transformations. I agree. And I think we should do a special builder on transformations just so y'all really get a chance to sink your teeth into that. What would you say the easiest question was? Number 1, that interval. Was that the parallel and perpendicular? Oh, no. Oh, just transitioning? Hey, would you like to know something? I'm proud to hear that, but would you like to know that this question right here, this skill, going from standard form to slope int, and then going from slope int back to standard, and then this one right here, going from point slope to point slope in, and it is the most missed question or skill type on the STAR test. So the ones that y'all found the easiest are the ones that are missed the most often. You know why? I'll tell you why right now. Why do you think this is the most often missed question? Here's why. Because y is not by itself, and you cannot put this in Desmos or TI. So this is a problem. You've got to be able to get y by itself. If you can get y by itself when you're doing the STAR test, you can go ahead and lean on that calculator, that Desmos. But until that time, that will be your roadblock. So the fact that y'all found it easy makes me feel great. All right, let's see how long this actually took. It took us 43 minutes to do 15 problems. Well, are we on track? What's 45 divided by 15? 3. Who was here on that place station when we figured out where we needed to be? Is this where we need to be? This is the appropriate solving speed for the STAR test, about 3 minutes per question. Okay, so great job, guys. We're going to call it a day there, and I appreciate all of your attention. Hope this was helpful.